we're going to demonstrate AVL-tree mode. An AVL-tree is a binary search tree where if I look at any given node and look at its subtrees, the two subtrees differ in height by at most 1. So in this case, this tree is larger by 1 in height than that tree because of that node right there. What we do is we mark each node in terms of what its balance factor is. Is it left-leaning, right-leaning, or balanced? And in order to be able to view balance factors, we need to go to our settings and turn on AVL mode. If we want to, we could turn on AVL and red-black at the same time. And I can imagine some demo you might want to do that. So this actually show it as both, but we're just going to focus on the AVL. So I just have AVL drawing mode on right now. And these large teal nubs here that are bigger and different color than the regular nubs basically indicate what the balance is. So if the left nub is the big one, then it's a left-leaning tree. If neither nub is highlighted as big, teal, then it's a balanced tree. And for example, in this case, with this subnode, this says this is a right-leaning tree. Okay, so that's the basic idea. So let's just do a couple AVL insertions and maybe a deletion or two to kind of get the idea how this will work. Okay, idea is we're going to insert just like a normal binary search tree on the way down. On the way back up, we're going to adjust the balance factors, and sometimes we may need to do a rotation or multiple rotations on the way back up as we're inserting and deleting. So let's add something here. 8089, okay, compare, 8089 goes right there. And by inserting this, this guy was balanced, but now it has to be marked as left-leaning. And this guy has increased in height, so we need to change the balance factor of this guy. The left subtree has just increased in height. The right subtree was larger, so now this guy is balanced. And that's all the farther we need to go. And now we have an AVL tree and everything is marked correctly. Let's add another one. 7485, 7485. That looks like it will be going right there. Okay. So we need to, we inserted here, we insert into something that was balanced. So we need to mark this guy now as being right-leaning. And that propagates up. This guy also gets marked as right-leaning. And now we get somebody who's already marked as right-leaning, and we have increased its height again. And so what that means is we need to do a rotation. Okay, so whenever we have something that's gotten out of balance by more than 1, we need to do a rotation. And in this case, the rotation is we simply mark these guys as balanced and do a rotation, and that takes care of everything. Let's do another one. 7622, 7622 would be going right there. Okay, we mark this guy as right-leaning. This guy is already right-leaning. We do the same transformation again. We clear the balance factors for this particular transformation, and we do a rotation, and now we have a valid red-black tree again. Let's do one more. 1780, 1780. That will end up going right there. And so this guy, need to mark him as being unbalanced. And in this case, we have we're coming up from this node's left. He was already out of balance. We made him more unbalanced. Now he's unbalanced by 2. So we need to clear those guys and do a double rotation, and that takes care of things here. Okay. We can do a deletion or two just to demonstrate that. So in this case, I will delete the 3, 3, 5, 3. I will delete that, but that means this guy is now balanced, which means it got shorter, which means I need to adjust that, which means this guy got shorter. I need to adjust that. That means that guy got shorter. Adjust that, and adjust that. And so in this case, we needed to adjust the balance factor all the way up, because as it turned out, we had the very deepest node in the tree. Okay, let's try deleting the 4038. It's a fully interior node. It's got 2 children, so we need to go find his in-order successor, which is right there. I will copy that data there, and now I will delete that. And what I get here is this guy was balanced. It's now out of balance, and that's all the farther I need to go. Okay, so this just is a demonstration of how we can use AVL mode to demonstrate AVL insertions and deletions.